Hello everyone. Welcome to the next lecture on the PY question series. Today we will discuss about matrix space. Myself Dr. Harish Garg. I will cover all those questions from the CSIR net examination 2011 to 2023. You can simply follow my YouTube channel where there is a playlist of the CSIR net. Here you can see the PY questions on the topic wise from the last 12 years. You can also see there is a PY questions related to some statistics portion which covered in the CSIR net mathematics exam. And you can see the complete PY question series related to the complex analysis, differential equation, Riemann integration, bounded variations series and many more available in this complete playlist. If you watch all these lectures very deeply, you will clear all those competition exam in a very simple manner. So first of all, before I start directly with the PY questions, let me quickly recall you the concepts and the various shortcut tricks in advance so that you can solve each questions within a 10 to 15 second trick. So you can stay tuned with this lecture. At the end of this, you will learn many shortcut tricks for solving matrix space problem. I will cover the few selected questions related to the matrix space. Any of the first of all, matrix space is an ordered pair. The first tuple is called as the set and this D is called as the matrix. And this D is again a function which is defined on the M cross N to R which satisfies certain properties. What are those properties? The first one is if I take x comma y, that is x comma x is always 0, and because it's a real, so I can say x comma y is always with a positive for all x and y in domain. And whenever x is equal to y, then you can say it's a 0. And this property is my second. Also, it must be the symmetric and the triangular inequality hold. If any of the function or any of the matrix is not satisfied any of the four properties, then we can say it is not matrix. If it satisfied all those properties, then we can say it is a matrix. In general, this set is either the Rn or it can be any particular set like of the Z or in any particular set Q or any of the things are here. The usual matrices are here. This is x and y is belongs to the my R. Then it's a usual matrix. If you call as a discrete matrix, then it is considered as a 0 if x is y, non-zero, that is a 1 if x is not equal to y. Apart from these two standard matrix, the maximum of the xi minus yi is also the matrix. Moreover, in general, if I call this in general, if x raised to power n minus y raised to power n, this is called as a matrix. That means it satisfied all those four properties if and only if n is my odd. And this concept is my very important for solving the MCQ questions in the GATE or CSIR net examination. Remember, whenever n is odd, this is always matrix. However, whenever n is my even, like x squared minus y squared, then this D is not matrix. Fine. Now, if you have proved that this is my matrix, then every convergent sequence, if you consider, it is also a Cauchy sequence. Now, if you have the three different matrices, that means these all are satisfied my four properties. Property number 1, 2, 4. Then based on this D1, D2 and D, we can form the linear combination like this. This is also the matrix space. Fine. Then the minimum of the 1 and D is also the matrix space. D over 1 plus D is also the matrix space. Alpha times, that is a scalar where alpha is my scalar number and it's a positive. Then it's also the matrix space, means if I prove D is my matrix, then 3D is also the matrix and sum of them is also the matrix space. However, the following, if you have the two matrix space, then the following are not always matrix. That means the product of the two matrices is not always the matrix because the triangular inequality property not hold. Minimum of the D1 and D2 is again not a matrix space. However, minimum of 1 comma this will be a matrix space, and clearly says if I say the maximum of 1 comma this is again not a matrix space. So you can easily prove that whether the one of the property is not satisfied. Now based on this simple shortcut trick that is given in your screen, I can solve all those PY questions in very simple manner. So before I start with the PY question, you can simply scan and join my WhatsApp group to get all those shortcut tricks in a very simple manner. Now let's start with the first question. Which of the following is or are metric on this? So first of all, as I mentioned you, this is said to be the metric whenever n is my odd. So clearly say this is my not metric. Yes, because in this case n is my 1, so yes, this is the metric. X cube minus y cube, again n is my odd, so this is also the metric. How you can say, and I already proved that, I already gave that a minimum of, now these are the metric, but these are the element. So what is that? We all know metric is always with a positive. So can you think about any of the x and y so that the minimum becomes negative? You can choose. If I choose x and y to be here, so what is the value of this? Minimum of x comma y, that is a minus of 2, which is not greater than 0. So therefore this is not metric. Right answers are my B and D. You can see how many seconds you are needed to solve the problem. Maximum 10 seconds you are needed to solve the problem. Okay, look at this one. Now you can see this is my Rn. So what is that? This is my simple usual matrix. This is my L2 matrix. That is the LP, L2 are there. So what is the meaning of that? D1 and D2 both are my metric. Fine. Now once both are metric, now we can see about that. So what does it mean? If they are there, then these are also the metric. Sorry, this sum is also the matrix. Fine. So this is satisfied. Difference we will see. Now you can see if I consider H is my this. So what does it mean? I already said H over 1 plus H also matrix. So if you look about the first option, what is that? If I call this is H and this is 1 plus H is also matrix. I also given you the shortcut tricks. If D is my matrix and alpha is my positive number, then alpha D is also matrix. And you can see e raised to power pi is my alpha, which is greater than 0. So this number is my matrix. E raised to power minus pi is also the positive number. So this is also matrix. Sum of the two is also matrix. The difference. Now as I gave you that this always metric. Fine. But the difference will not be the metric. Why? Because for the metric we know this value is a greater than 0. For this D2 is also the greater than 0. But what about the difference? It may be greater than 0. It may be less than 0. So that's for this is not metric. Because once it's less than 0, then it is not metric. So the right answers are A, C and D are my right answer. And you can see, you can easily solve this problem with the help of this concept. This and D over 1 plus D. So if these two are there, based on this option is correct. Alpha D is my this option correct, and this is my this option correct. Look at this another one. If which of the following are metric on this? F is my continuous function. So look at that. What is the supremum? Is nothing but the maximum of this. So supremum is always be the metric on this. Infimum, that is a minimum. Minimum will not be this. Minimum will not be the metric of this. What is that? This is nothing but the L1. This is a matrix. This is my L1. This is the matrix. Supremum is the matrix. So sum of the two matrix is also the matrix. So the right answers are A, C and D are my correct answer. You can clearly say in this case the triangular inequality does not hold because of this infimum. Look at this another one. If D and D dash are my matrix on the matrix space, which of the following are here? What is that? Sum of the two matrix. Fine. This is the product. As I gave you, the product will not be a matrix. Clearly say that triangular inequality will not hold. Maximum of this is a triangular inequality. Minimum of this is not always true option. So that's the right answers are my A and C are my right answers. Let alpha is there this is my greatest integer smaller than of this, and it is defined as, matrix is defined as x minus y of this, then which of the following statement are my correct? I think very simple. What is that? D of x comma y is 0. We all know this number will be 0 when it will be 0 when x is lies between here. Fine. So if I choose x is my 1, for example, y is say my 1.3, then what is the distance between them? It is x minus y. So mod of this is my 0.3. What is the greatest integer of the 0.3? 0. But it doesn't implies x is equal to y. He said if and only if, but he said x is not equal to y. So first option is cancel. Look at the second. D of xy is d of yx. So clearly say because of this modulus sign, it is a mod of this. So this option is correct option. D of x comma y, and D is not a matrix. Clearly say this option is not satisfied. So this option is not a matrix. This it's not a matrix correct option. This is a triangular inequality. Again, that's a very simple. If I choose x comma y, look at that. This is a x comma y. So I can choose x is 0. Y is distance between them is say 1. So what is the left hand side is 1. Now I have to check the distance of x z and z y. So what is that? If I choose x of z, if I choose the number is 0.2, what is the distance? What is the matrix of x comma z? It is the greatest integer of 0.2. So that is my 0. What is that? Y of z is a 0.8. 0.8 is also 0. So can it be true? Is it less than of this? It is not less than. So it means this option is also cancel out. So the right options are B and D are my correct options for this example. Very simple. You just look at the simple definition and provide the very simple values. Okay, look at that. Which of the following is not the journal matrix, where this is given to you as a matrix? Which of the following is not? Okay, what is that? This is my discrete matrix. So fine, yes, this is the matrix, but we need a not. Minimum of this is also the matrix that I already gave you the tips. Yes, too. Look at this one. Okay, if D is a matrix, whatever the value of the alpha, this is said to be the matrix if alpha is my less than 1, and if alpha is my greater than 1, it is not matrix. Fine. So now you can see that this alpha is my half. Alpha is less than 1. Yes, this is a matrix, but this is not a matrix. So the right answer is my A is my correct option. Why? Which option is not satisfied? Clearly say it's a triangular inequality properties not satisfied. Okay, let D1, D2 and D3 are the matrix, and at least the two elements which are the following is not a matrix. Only one correct option. D is given to you as a matrix. Fine. Okay, if D is my matrix, then we all know D over 1 plus D is also matrix. So yes, this is the, yes, it is a matrix, but we need a not. What is that? If I know if D is my matrix, alpha into D is also matrix, provided alpha is my greater than 0. So I can say this is 1 over 3 D1, 1 over 3 D2, and here, since all of them are my matrix, so this and this are also matrix. So once they are matrix, then the sum of them is also matrix. So it means yes, the last option is also the correct, is a matrix. Now look at that, either the minimum or the maximum. Look at that. If it is not a 1, as I gave you the tips that this is a matrix, but it's a 2. Now look at that. If D is a matrix, I can check about this property. What is the D of x comma x is 0. Fine. Or yes, d of x comma, okay. Now your target is to check whether, yes, if I call this is my h, fine. So then what is my h of x comma y? For the first case, it is a minimum of 0 comma 2. This is 0, fine, h of x comma x. For this case, h of x comma x is maximum of 0 comma 2, which is 2, which is not equal to 0. When you consider same element, it must be 0. So it means it not satisfied, so it is not a metric space. And yes, this is my metric space because only the one correct option is there, so all are properties satisfied. So the right answer is my B is the correct answer. Okay, look at this another one. It's a December 2020. P is a metric which is defined here. Which of the following statements are my correct? Okay, so if P x comma y is 0, if and only if x comma y is 0, when it will be 0? Let's say if when it will be 0. So as per the definition, it will be 0 depending upon that whether x is 0 or x is non-zero. So in either of the case, we can say x is 0 or y is 0. So he said if and only if both are my 0. That's clearly say it's satisfied properties. P of x comma y is my greater than or equal to 0. Because of this modulus value, it is obvious that it's a greater than 0. P of alpha x. So what is the alpha x of alpha y? Fine, where for all alpha in the R. So it is alpha x and alpha y. So depending upon that whether x is non-zero or x is 0. So it is written as alpha times x and of y. Fine, because if x is 0, then this value will be my alpha y. I can return this number as mod of y. So this number is when x is 0, this is P of xy. Second case, if x is my non-zero, then this number will be my mod of alpha x. So then it number is again P of xy. So this option is also correct option. Look at this last option. If on the left hand side, so this number, again there are the two cases, whether this is my 0 or this is non-zero. If this is 0, then left hand side will be my y1 plus y2. Then what is my right hand side? Now sum will be 0. It doesn't mean that x1 is 0, x2 is 0. It doesn't mean, because if we choose x1 is my 3, then x2 will be my minus 3. It means this value, in this case x1 is my non-zero. So on the left hand side it is my x1 and it is my x2. So you can see we can't always say it is true. We can choose any pair of them like 0, 4, 4, 7 and many there which is not satisfied. So the right answers are my A, B and C are the correct answers. Okay, look at this another one. X is a vector of D. Okay, so firstly I can choose the value of the D as a 1, so that my calculation becomes simple. P is my greater than 1, so the answer is not depending upon P. I can choose P is my again a 1. Then this X is simply my x1. Fine. Then okay, then if I choose simply dx, then both the values are same. Fine, these are single element. If I choose this is my 2, then the elements are my here. Fine. Then if we look about that, this is a norm of x1, norm of x1, x1 here. So P is equal to 1. So that means this value becomes my P is equal to 1. So it is nothing but x1 mod plus x2. And x of infinity means that is the maximum of mod x1 plus mod x2. Fine. Then which of the following inequality hold for this? Okay, so firstly I can choose about 1 and infinity. I can check about here. Choose any pair of this. It's a part of D2. Choose any value from this pair. Choose any value. So the smallest one is I can choose 1, 0. Then what is the value of the norm 1? So 1 plus 1 is 1. What is the norm of this is maximum of comma, sorry, it's a comma. Maximum of this is again a 1. So we can check about that. 1, is it greater than of 2 times 1? No, this option is cancelled. Look at this option. 1 is less than of root 2 into 1. So but we can't say, because this is a one counter example, we always discard the option. Okay, now there is a need of the norm 2. What is the norm of 2? Again, p is equal to 2. So this value will be my x1 square plus x2 square. Now we can see about here x1 and x2. Okay, if I choose this value for here, what is this value? 1 plus 1. 1 plus 0 is a 1. So 1 is less than of root 2 into 1. Again, this is not the counter example. If I choose the another pair, let's say 1 comma 1, then what is the value of this? 1 plus 1, 2. This value is maximum of this is again a 1, and this value will be 1 plus 1, 2 of root 2. Fine. Then this value is my 2, which is less than of root 2 into root 2. So which is, again you can see, which is not, which we can't satisfy. Look at this option. x1 is a 2, which is less than of root 2 into 1, which is not satisfied. So this option is also cancelled out. Look at this one. Norm of 1, 2, greater than of root 2, greater than of 1, satisfied. In this case also satisfied. So we can't discard the A and D option. Now what you can think about the A and D option? So now what is that norm of 1? This and this. Okay, I can start from here, this minus this. What is that? This is x1 square plus x2 square plus 2 times x1 x2 minus of this value. Fine. So these values are cancelled, and because of this modulus, it is always greater than or equal to 0. What does it mean? Norm of x1 is always greater than of norm of x2. First satisfied. Now since what is the x2 is this root of this, and it's a maximum of this, it is always greater than of this number. So this option is the correct option. Look at this option. Now since I consider D as a 2, so my target is to prove this number is root 2 times of x2. So I can start from square of this minus this square. So what is the value of this? Is x1 square plus x2 square minus x1 plus x2 square mod of this. So what is that? If I open this, 2x1 square minus x1 square minus x2 square minus 2x1 x2. So it is my x1 plus x2 square. So it is my x1, this is my mod, minus square, which is always greater than or equal to 0. So what this means is root 2 x2 is always greater than of norm of x1. So yes, this option is also correct. A and D are my correct options. Okay, look at this another one. Which of the following are my metric? So supremum is always a metric, infimum is not a metric. 0 to 1 is nothing but my L1 norm. So it's a LP, so L1 it's a metric. This is the sum of the two metric, because this is a metric supremum by first part, this is a metric by the C part. So yes, sum of the two metric is also metric. A, C and D are my right answer. Look at this another one. Which consider the following subset, this. Which of the following are my compact? Okay, now they are not talking about the metric. Compact means you have to prove is a closed and you have to prove it's a bounded. So look at the first option. What is that? It's a ellipse. Fine. So it's a ellipse is only on the boundary. Only on the boundary. Fine. So now can you say about that this is a metric? How you can it's a compact, it's a closed and bounded. Clearly say it is a closed. It's equality. Yes, fine. So if you look about this, the neighborhood is also, it is my closed Fine. It is also the bounded. So that means this is my compact. So A is my compact, but he said A is not compact. This option is cancelled out. Fine. Now if you look about this not compact C, what is that? C is, how you can say C. Okay, C. What is that? Ax plus by plus x and y are there. So what is that? Ax plus by plus 5 is equal to 0. What is that? This is a straight line. Fine. So this is a straight line passing through minus 5. This is my like here. Because depending upon that, if I choose A and B, both are my positive, then it will be my minus 5 over something, and it will be my minus 5. Sorry, this is not the line. This is my line. Fine. And clearly say this line is my unbounded. Fine. So once this is unbounded, it means it is not compact. So C is not compact. So C is not compact. Fine. C is not compact. Fine. C is not compact. Fine. Now I have to check about the capital D. Ax is equal to by square, means y square is equal to a over b x. This is a parabola. Fine. So it is a closed. Fine. And is it a bounded? No. What can you say about that? Is it closed or bounded? This is my, how you can check about, is a this is a curve. Always remember, whenever you have the curve, it is always closed. So this is the closed, but it is unbounded. You can see that because this is the y square is there. This is the unbounded. Once this is unbounded, it means it is not compact. So this is not compact. D's are not compact. D is not compact. So that's fine. Now we can check about the B. What is that? Again, it's an ellipse, but inside the circle. Once you can say it's inside the circle, what does it mean? This is a closed as well as the bounded. So B is my compact. So but he said B is not compact. This option is cancelled. Now we can check about the E. What is that? X cube plus y cube is equal to 1. So clearly say this is unbounded. How? You can choose any of the numbers, say n raised to power 1 by 3. Y is, how you can define as, is a 1 minus n raised to power 1 over 3. It satisfied this property, but clearly say this is my unbounded, because n is my integer, and in any number is unbounded. So this is my unbounded. So E is my, if it is unbounded, it means it is not compact. E is not compact. He said E is compact. This option is cancelled. The left option is B is my right answer. Okay, which of the following are the Rn? Firstly, I can choose n is my 1. Fine. So this first example becomes my mod of x1 is less than 1. This one is simply x1 is equal to 0. Fine. This one is simple x1 is my greater than 0, and this one is x1 is less than 2 raised to power 1. What is that? Mod of x1, so that's the minus 1, 2 plus 1. But the boundary points are not included. Once the boundary points are not included, they are the bounded but not closed. So if they are not closed, it means they are not compact. X1 is equal to 0. X1 0 means this line is a y-axis, and clearly say this is my unbounded line. Fine. Y-axis or x-axis both are my unbounded. So this is option is cancelled. X1 is greater than 0. X1 is greater than 0. That means x1 can be 1. X1 is okay. I can choose as n is 2. Then it means x1 is greater than 0, x2 is greater than 0. That means this portion, first quadrant, and clearly say first quadrant is my unbounded. So this option is also cancelled. Only left option is my here. You can see x is, sorry, is equality also. Is a closed plus bounded. So the right answer is my D is the right answer. Moreover, if I say x1 is only x1, so that means only this line x1 is here, so which is again a line which is unbounded. Which of the following are my convex? I can draw the graphical representation. Mod of x is 5, so minus 5 plus 5. Fine, lines are equality hold. Y is equal to 10, y is equal to minus 10, so which is a closed. You can see I can take that 2 point which is always inside it, it is a convex. So first option is correct. X square plus y square is equal to 1. So that means only the boundary points. Fine. Is it a convex? No. If I take the 2 points on this, if I join them, these points are not belongs to this one. So this option is cancelled. Y is equal to x square. So that's a parabola. Fine. So I can shade the portion. What is the shading portion? I can choose the point whether 1 comma 0 satisfied. 0 is greater than 1, not satisfied. So it means I can shade this portion. Fine. I can choose any point here. Let's say 0 comma 3. It's satisfied. And is it a convex set? Yes, you can choose any 2 point. And since it's equality also, I can choose the 2 points. It always lies inside it. Look at the last point. Again, y is equal to x square. It's a parabola. Fine. Now in this case, if I choose any point here, let's say 0 comma 2, is it satisfied? 2 is less than 0. No. If I choose any point here, say 7 comma 0, 0 less than 49, satisfied. It means this portion is my here. Is it a convex set? No, because I take the 2 point here, line joining them which is not belongs to this line, does not belong to the shaded portion. So the right answer is A and C are the correct answer. Which of the following are my compact? Again, I can draw the graphical representation. X, 1 and minus 1. Mod of y greater than 2. What is the meaning of the greater than 2? This is greater than of the 2 and minus of 2. So this is the portion. So clearly say this is my unbounded. Fine. This portion is also unbounded. If this is unbounded, it means it is not compact, because compact implies closed plus bounded, but it is not a bounded. Mod of x is plus 1, so it is a minus 1 plus 1. Y square is less than or equal to 2. What does it means? It is minus root y minus root 2 to plus root 2, that is here. So clearly say equality also hold, which is a closed as well as bounded. So yes, this is my here. This is the ellipse. You can see this is my ellipse, and equality also here, which is the inside portion, which is a closed plus bounded both. So yes, it is a here. X square is less than of, so what is that? This is x square minus y square is less than of 5. What is that? This is the hyperbola. Fine. And we all know hyperbola is my unbounded. So once it's unbounded, so it is not a compact. So the right answers are B and C are the correct option. Which of the following subsets are not compact? So it means we will prove whether either not closed or not bounded. Either one of them will satisfy. X square plus y square is less than or equal to 1. It's a closed. Fine. It is clearly say it's a closed. It is also the bounded. It means it is a compact, but we need a not. This option is cancelled. X square plus y square is greater than equal to 1. What does mean is greater than is? We will look about the outside portion. So what is the outside portion said? It is my unbounded. Once it is unbounded, it means it is not compact. So it means second option is correct. X square plus y square is strictly less than 1. That means it's an open interval. Fine. So what does it mean? Once you consider this is the open interval, can you say it is a, this is my not closed first of all? Fine. It is a boundary, but it's not a close. If not close, it means it's not a compact. x square plus y square is equal to 1. So that means only the boundary points. Once you consider only the boundary points, that means it's a closed plus bounded as well. This means this is a compact, but we need a not compact. The right answers are B and C are the correct option. Okay, which of the followings again are the compact? So X is a union. Fine. So A and B, if you prove that these are my compact, fine, union is my compact. Now look at that. This is my circle, center is my 1, 2, radius is my 9. So it look like say here. Fine. And it's only on the boundary point, so it's a closed and bounded. So yes, this is my compact. If I look about here, collection of all those pairs such that y is equal to 3, only this line, so which is unbounded. Fine. So since it is unbounded, it means this is not compact. So if this is not compact, it means this option is cancelled. Look at the second option, we will discuss later, it's a very lengthy. Okay, look at this one. What is that? It is just like say x square plus y, x square 2y square minus of 3. So can you think about that? It is, what is the nature of this? Okay. It is a hyperboloid. Sorry, it is only the z. Okay, it's a hyperboloid, or this is a z square. Okay, if it is a z square, then again there is no worry. If it is a z square, what is that? Because of this negative, it's a hyperboloid and it is always the unbounded. Fine. So once it's unbounded, it is not compact. What is that? This is equality. It's a compact plus it is a bounded as well. So yes, this is a compact set. Now look at that. It's a collection of all those 1, n. So yes, this is a closed plus bounded. Limit point of this, fine. 0, 0 is a singleton, fine. This is the x-axis. Point on the x-axis where m is a integer, not 0. All are my closed and bounded. You can clearly see the limit points of concept. So this is a closed, this is a bounded. Yes, this is my compact set. So the right answers are B and D. You can watch my previous lecture related to the closed and the bounded sets. That is a limit point. Okay, look at this another one. Which of the following sets are connected? Now this is the third category. Fine. The first category we have discussed how you can check about the metric. Type second we have discussed how you can check about the compact. Now the third is we will check about the connected. Whenever you are talking about the connected, always draw the diagram. What is the D of 0, 0? 0, 0 is 0, 0. That means x square plus y square is less than r is my 1. It's a circle with center here. Union 1, 0. This is my 1, 0. 2, 0. So it's a 2 and 0. Center is my 2, 0. This is my 1, 0. It's my 2, 0. And the radius is 1. So it is passing through here. Clear? Now, can you say it's a connected? What is the meaning of the connected? So if I take any point from here, I can easily move. If I take any point this, because of this point included, I can move on this side. Yes, this is connected. Fine. Look at the second point. D of 0, 0, radius 1, 2, 0, radius 1. Fine. But you can see it's a open interval. It's an open interval. That means this point is not included. This point not included. So it means you are unable to start. If you start from here, you are unable to move at this point. Fine. If you start from the B, you are unable to reach at the point A. That means they are my disconnected sets. So this option is cancelled. D of 0, 0 again is a circle. 1, 0 is my here. 0, 2. So this is my 0 and this is my y minus 2, less than of radius is 1. So this is my 0 comma 1, this is my 0 comma 2. So this is my here. Fine. Again, because of the strictly less than sign, this point is not included. So once this point is not included, you are unable to move from B to A. So that means this is also disconnected. So this option is also cancelled. Last option is, again, is a 0 comma 0 and 2 comma 0. So 2 comma 0 is here and it look like say here. Again, this point is not included. You are unable to move from one set B to A. So again, this is my disconnected. So the only option A is my correct option, because this set, this point is included in this L. Okay, which of the following is my connected again? So C of A R. So what is the C of 0 comma 1? X square plus y square is 1. X square plus y square is 1. That is only on the boundary points. 0 comma 2. X square plus y square is equal to is a 4. So that means circle of radius here. Only boundary points. So clearly say they are my disconnected. You are unable to, if you start from this boundary, are you able to reach at the outset? No, because these elements are not included. Only equality. So this option is cancelled out. Look at the second, 0 comma 1. Again, this is my 0 comma 1. 1 comma 3. X minus 1 square, y square is 9. So center is 1 comma 0. Radius is my 3. So this value is 4. This value is my, radius is my 3. So it is my minus 2. So this value is my here. Fine. Again, you are unable to reach from this inside boundary points to the outside points. Again, this is my disconnected. This option is also cancelled out. Again, 0 comma 1 is a circle, center 0, radius 1. 1 comma 1, that means x minus 1 square plus y square is equal to 1. So center is my here, radius is my 1. So that means it is like this one. Fine. Now look at that, we only consider the boundary point. If I start from here, are you able to reach for the blue color? Yes, you can reach and you can go from this side. Fine. Again, you can reach here and you can move on each of these colors. Fine. So yes, this is my connected set. So this option is correct option. Look at the last option, C 0 comma 1, here 2 comma 1. So 2 comma 1 means x minus here plus y square is 1. So 2 comma 0, this is my 1 comma 0, 2 comma 0 here, radius is my 1. So this is my here. Fine. This is my 3. Now, is it possible you can start from this point? Is this point included? Yes, because this is equality. So you can go from this side, you can then go from this, and then again you can go from his. Yes, this is my connected set. So right answers are C and D are my connected. Always remember, whenever you are asking, whenever the question is related to the compact or connected or convex, fine, always draw the figure. Once you draw the figure, you will get your answer within a 10 to 15 seconds. Okay, now look at this one. Now you can see that there is nothing is to be given about the numerical number. It means we have to use the results. Now what is the tips for you? First of all, you can read the statement. X is the connected subset of the R. Fine. X, what is the nature of this is? It's a connected. Fine. Okay. Now what is the tips for you? If I say A is the subset of the R, which is my connected. Fine. Then the only nature of this X is either it is my singleton or it is my interval. That's the only properties of this A. If every element of the X is irrational, it means it is not singleton. That means it is either the open interval or the closed interval. But look at that. Every element of the X is irrational. What does it mean? If every element of the X is irrational, every element of the X is no, every element of the X is irrational. What does it mean? Yes, definitely every element. So it's not a singlet, it means it is my here. So what is the meaning of that? And the cardinality, what is the cardinality of the interval? It's uncountable. Fine. But no, every element of the X is irrational. But the interval contain the rational part also. So definitely it is not an interval, it is a singleton. It is a singleton. Why? Every element of the X is irrational, but it consists of rational also. So it means it is not an interval, it is only singleton. If it is a singleton, what is the cardinality? Cardinality is my 1. Yes, that's correct. Every element is, because of the word is every element is irrational. So but this interval, like say 1, 3, so root 2 is the irrational number, but 1, and there are so many number which is irrational, but he said every element. So that means it is not an interval, only singleton element left behind. X is a metric space, A is the subset of the X, and this is my connected. Fine. Okay, X is my metric space, so I can again use this property. Fine. I need to subset of the R. Remember, this is a subset of the R. So if I choose X is my R, which is a metric space. Fine. Then again, this is either singleton or interval. Fine. Now look at the elements of this with at least 2 distinct elements. So it means it is not singleton. So it means this is a part of interval AB or closed interval AB or semi-closed interval AB, any of the form, that is an interval. Then the number of the distinct points in the A. What does it mean? With at least 2 distinct, how many distinct points are there? What is the cardinality? Uncountable. So you have the uncountable distinct point in A. So the right answer is only D is the right answer. It's a finite, so that option is cancelled because the cardinality of this interval is a C, is a uncountable. So it's a countably finite, cancel, 2 cancel, only option is D is the right answer. Okay, X comma D is a metric space. Again, A is a subset of the X, but it is not given that A is my connected. Look at that. If it is given that A is a connected, then only is a singleton or interval. But in this case, it is not given. Then how you can think about this problem? Okay, I think very simple. First of all, I can tell you a simple property. D comma S is 0 if and only if either X belongs to the S, fine, or X is the limit point of S, fine. Or what does it mean? X either belongs to the S or X belongs to the limit point. That means you can say it's a S closure. Fine. So what is that tips for you is, whenever you have given this is 0 if and only if X belongs to the closure. This is the simple rule for that. Or you can see about here. Now look at that. D of X comma A is my 0. What does it mean? It means in this case S is my A. Fine. It means either X belongs to the A or X is the limit point of A. What does it mean? A closure is my this. It means A is my, what is the definition of this? This is my dense in X. This is my here. Fine. Now you have to think about whether A is equal to X. Can you think, okay, I can choose X is equal to R. Fine. You can think any of the A. It may be connected or it may not be connected. Choose any subset of the R. The simple one is Q. Fine. Such that distance of, and we all know distance of this X over Q is always 0 for all X in the R. Fine. This property is satisfied because A is my Q. Fine. So this property is satisfied. What is the Q? A is equal to Q, but he said A is equal to R. This option cancel. A is compact and closed. What is the Q? Q is neither compact, neither open, nor compact. Fine. So this option is also cancelled. Right option is only C is the right answer. Always remember that whenever it's an infimum of condition given, distance will be the 0 if and only if X is either that belongs to that element set or the limit point. Okay, A is the closed subset of the X. Okay, A is the closed subset of the X, of the R, sorry. Fine. Okay, first tips. We all know in the R the only subset which is open and closed. Can you tell me what is that? What is that subset? The only subset which is open and closed are either the phi or R. But he said A is neither the phi nor the R. Fine. Now what you can do, think about that. Take any subset of the R. So I can choose A is the subset of R. So you can choose A is my Z. Z is my subset of the R. Fine. Now what is that? A is a closure, compact, count. Okay. Is Z is not bounded. Fine. It means it is not compact. So it means compact option is my cancel. Now closure of this here. What is the closure of this? It's a phi. Closure of this, what is the phi of this is again a phi, but it is not equal to the A. What is the A is Z. It is not satisfied. Closure of the interior. So what is the interior of the Z? Interior of the Z is phi. Closure of the phi is phi. So but it is not equal to Z. This is cancelled. A is countable set. A is a countable. What can you think about any of the uncountable set which is a subset of the R? Yes. Say, this is a subset of the R and it is my uncountable. Fine. So this option is cancelled. So what is that? A is a closed subset. The only subset which is open and closed is this, but which is not possible. What is that? A is neither the closed nor the open. So this option is nor the open is the fine. So also you can say it's not a closed. If it is not closed, it means it is not compact. So the right option is D. I think this is you can solve this problem by the help of this simple remark. Okay, for every non-empty subset, a point D is connected such that again you can see the same infimum. So I can use the same remark. Fine. So I can write for you here. D of S is 0 if and only if X belongs to the S bar, or X belongs to the S, or X is limit point of S. Now look at the first option. S is my closed. It means S is equal to S complement, and D of S comma S is strictly greater than 0. What does it means? If this does not satisfy, it means X does not belong to the S and X is not the limit point of the S. Fine. Then X is not the accumulation point. That means a limit point. So that's true. Either this property is satisfied or this satisfied, because this is not 0. It means X is not point. If S is open and again this property hold, what does it means? S does not belong to the S, or X is not the limit point. Fine, this property is again hold. So what does it mean? It is satisfied. Look at the third option, it's a B option. Now look at the C option. S is closed, D of S is greater than 0, again this property, then S does not contain S. Fine, this property here. Fine. So which of the following is a correct statement? Okay, these three are correct statement. Look at this one. S is open and now it's a 0. So this is open. Now S comma this is my 0. What does it means? X belongs to my S complement. S is my open. It means this is not equal to here. Fine. Then if S is my open, what does it means? Now okay, fine. Since S complement S closure is not equal to the S, what does it means? X does not belong to the S, but he said X belongs to the S. This option is cancelled. Fine. Otherwise, because this option is discard, so I can provide the counter example very easily. Fine. S is the subset, so I can choose the subset of the R. Choose any subset, say interval 0, 2 or 0, 1. And another thing is S is my open, so fine. Distance of them is a 0. Can you choose X so that distance of this will be 0? What is the distance? Is the minimum of each element. So I can choose in such a way so that the minimum will be 0. Can you think about that? Any of the distance, I have to choose X is my 0. Fine. Okay, because 0 is also the part of this, so I can choose any of the other set, say 1, 2. Fine. Then here, what is the distance of them? 1 minus 1, 0, and 1 minus 2 is 1. So the minimum infimum is 0. So can you say X, which is 1, belongs to the S, is an open interval, so S does not belong to that. So that's why the right options are A, B and C are the correct option. Okay, look at this another one. F is a mapping, F is a metric function from X to Y. Okay, what is the nature of this? F is a continuous? No. Then a Cauchy sequence Xn. It is given that this is a Cauchy sequence. Fine. Then which of the following statement hold? If F is a continuous, okay, so F is a continuous mapping, I can easily choose F of Xn is a Cauchy mapping. Okay, I can choose this value. Fine. Can you think about any of the Cauchy sequence? Clearly say this is my Cauchy sequence. Fine. Then what is my F of Xn or F of 1 by n? It is my n. This is not Cauchy. Fine. So it means this option is cancelled. Okay, I can choose any of the X, say 0, 1, Y is my 0, 1. Fine. F of Xn is my Cauchy. Now in this case it is given that this is my Cauchy. So it means, and then F of Xn is always convergent. So I can think about any of the sequence which is not convergent. That's fine. If I choose this value, fine. So what is the F of Xn is? Xn, according to this, since Xn is my Cauchy sequence, so this Fn is my Cauchy sequence. It is given to you. Fine. If this is my Cauchy, then is it convergent? How you can prove that it's a convergent? If I choose again 1 over n, fine. What is the limit for whenever you are talking about the convergent? You have to check about the limit. What is the limit is 0, but 0 does not belongs to this y. Y is my closed open interval of the 0, 1. Fine, but it does not belongs to this. It means it is not convergent. If f of xn is Cauchy in y, then f is my continuous. Can you think about any of the function which is discontinuous but still it has a Cauchy sequence? Can you think about any of the discontinuous? Oh, there is no, okay, this is, look at that, xn is always convergent. Same example, because look at that, if I choose xn, I have to choose xn is a Cauchy sequence, so 1 over n, this is a Cauchy sequence, fine, and is always convergent. Again, if I choose the limit, it's a 0, but 0 is not belongs to the open interval of 0 comma 1, so therefore this is option is also cancelled. Only right option is my C is the right. Okay, look at this another one. What is given to you? A is the subset of r raised to power p. I can choose p is equal to 1. Fine. So that my calculation becomes a simple. A is the subset of the r. Denote x is my here is an infimum. Then there exists. Okay, again this is, but in this case it is not given as a 0. If it is given as a 0, then I can use the same previous rule. X belongs to my A closure. But in this case 0 is not given to you. Okay, A is a subset of the R. Choose any of the subset. Any of the subset. Fine. Now I need a X also. X belongs to the R. Now you can choose X belongs to the R such that this distance will be infimum. So think about any of the distance, choose any one of them, say 2. What is the minimum of this? It's a 2, it's a 1, so the minimum is my 1. So this value will be my 1. Now then there exists a y naught. There exists a y naught in A such that distance of y naught comma x will be my 1. Can you find, because your x is my here, can you find any of the y naught in this case so that the distance becomes a 1? Because it's a single element, this will be happen only when you take y naught is 1, then only, but it's an open interval, so it means there does not exist any y. Fine. So if I choose here, it means what is my A? A is my empty set. Fine. If I choose this counter example, there does A is the empty set, but he said non-empty subset of the R. This is cancel out. Fine. A is a non-empty bounded subset of R. Here. Now it's a compact. Fine. Now you can think about that. How you can think about any of these property? A, okay, I can give you again, y naught x is x comma A. Look at that, this x, this y naught is in my A, so this happen only when your A is non-empty. Fine. This will be non-empty only when it is a non-empty closed and compact. Okay, this is the simple, this relation hold, because in this case it is not hold because A is my open, but if I choose A is my closed, then there exists a y. Fine. Then there exists a y naught, so A must be the non-empty closed and the compact set. So A is the any closed non-empty set. Fine. Fine. A is any non-empty bounded, because in this case closed word is not given, so that's why this option is cancelled. It's a closed. Fine. In this case also closed is not given, so it may be open, so that's why this option is cancelled. So the right options are A and C are my right answer. You can, instead of consider this example, you may choose this as a shortcut tricks for you for this example. A is always a non-empty closed and compact. In this case closed is not given, it means A may be open, may be closed, so that's why this option is cancelled. Okay, for the two subset x and y of R, x plus y is here. Okay, I think that's simple. So x and y are open, that's a simple result. If either x or y is open, this implies x plus y is open. But here both are there, fine. Similarly, if x and y are my compact set, then sum will also be the compact set. If x is closed, now again, if x and y are, if either x or y is closed and other is compact, fine, then the sum will be closed. Fine, so this option is also correct. X and y are the closed set, the sum will not be closed. One of them must be compact. So this option is false statement. So the right options are A, C and D are the correct answer. Okay, let X is the connected matrix space with at least a 2 point. X is the connected matrix space. Fine. Then which of the following is necessary? So let's say matrix space. I consider R is my matrix space. This X property of the X is connected. So as I told you, what are those choices? Either it is my singleton or it is my interval. Now look at the property, at least 2 element. It means it is not singleton. It means this is my interval. Then finite. Okay, what is the, now they are talking about the points. What is the cardinality of this? It's a uncountable. So it acts as uncountably many points. No such x exists, cancel out this, because you can consider any of the interval 1, 3 or anything else. So it has uncountably many points is the right answer. You can see how many seconds you are needed to solve the problem. Okay, look at this another one. X is my matrix space. F is a function such that f of x, f of y is less than of this. Now matrix is not given to you, so I can assume a standard matrix. Fine, standard usual matrix, that is x minus y. So what is that? This means f of x minus f of y is here. Fine. So what does it mean? For every x and y, which of the following are necessary to? What does it implies? It implies f is my continuous. Why? It's very simple. What is that? It means f dash of x is my less than 1. That means f satisfied my ellipsis continuous. If f is my ellipsis continuous, it means f is my continuous. So f is my continuous is the correct answer. Because it's a part B, only one correct option is there, so rest options are cancelled out. Moreover, you can easily prove that f is not injective. You can choose any of the 2 points, which is a very minute difference between them, and still it is a not same. So the right option is my A is the right answer. So you can see it's a very simple, you can solve all these problems in a very simple manner. We will see the next lecture on the more properties of the connectedness. Till then you can simply scan and join. I hope you can like, share and comment on my video. Best of luck students. Happy learning.